All right, I'm setting up my PCM, just making sure that some of the settings are correct to start my engine on the stand before I put the wiring harness into the car. Okay, in one of my other videos, I showed this quickie programmer plug I made in case somebody wants to do this so you don't have to do it in the car. It's real simple. Go online, pick up a brand new ODB2 connector with the pins that you would just crimp the pins on yourself, and one of these black connectors. So all I'm using is a battery, 12-volt battery. I'm gonna plug this so I'm not live. My on-off switch, which simulates my key on ignition switch, ground, and a black connector. So I wanted to put this out there so that you can just watch this one video and watch my progress. Okay, so the programmer plug system here, the wiring, very simple. This black connector, remember I showed you how to count the pins. When you're looking at it, it's 1 through 10 going this way at the top row, okay? So pin 9 is your ground. Pin 19 is also ground, which is right next to it. Right there. Pin 11 is your switch, 12 volts, which I give it my ignition switch. Pin 29 is your hot wire, 12 volts. It goes right to my 12 volts, right to the battery. And then 34 and 35. So if you're counting from the end, 38, 37, 36, 35, and 34, that's your CAN minus, your CAN bus signals, your minus and your plus, okay? 34 is plus, 35 is CAN minus. So then now, when you pin out your ODB2 connector, the pins count, let me unplug this. The pins count from this way. 1, 2, 3, 4, 5, 6, 7, 8, okay? They go across that way. So if you see my wiring, counting from the right, 1, 2, 3, 4 is my ground. 1, 2, 3, 4, 5, 6 is my CAN plus. So you would hook your CAN plus pin 34 black connector just like that. And then pin 35 is your CAN minus. You would hook that right to that. And then pin 16, if you look at my plug here, pin 16 is the last one on the bottom, which should be the farthest lowest right one over here, plus 12 volts. So that would go right to that. And then your ground, which could also go to the 2, 9, and 19, and your battery. So whenever I have ground here, you'd send it to your battery ground, your pin 19, and also your pin 4. Very simple. That way you can program in the comfort of your kitchen or wherever. This was my MPVI 2, which I found on Marketplace for $200. And you would just need 2 credits for $100 to make it save. You can read and write on your PCMs all you want, but you cannot write to it until you buy the credits. And with these, it's 2 credits per PCM. All right, so let's get to this. I already saved. I already made a change in here for the start. Here, let me show you that real quick. Under communication, I had to change the ignition start over CAN. And I think I changed one of these up here. But this is how mine are set right now. Enabled, enabled, disabled, enabled, 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 and then the rest disabled. This is under the communication tab under systems. I'm just gonna see if this gets it to start when I hit my start button. All right, just a quickie. Make your connector up. There's another video on how I tested this and made it, but I'm trying to incorporate all these small short videos into my pace car video. Okay, I've got everything hooked up. I did the throttle, gas pedal learn test to program it to this PCM. Did the throttle follower test again. Had this running for a second, but I have to redo it because I had the radio running in the background because of the copyright stuff. So this, just so you can hear it running. Let me clip this on. This is my relay now. I just have instead of a push button because I need my hands. This clicks the relay, which enables the start run circuit on that yellow wire. So when I hit this, it should start. Oh, turn on the ignition. It's a handshake, the fuel pump. All right, so you hear it running. It means the skim's removed. Everything's enabled for my start switch. And now I'm gonna take this and put it in the car and then get that engine running. All right, let's go. All right, putting my wiring harness in the car. Got everything plugged in here where I'm gonna try to position it. That's going underneath the console if it'll fit. Gas pedal wire is gonna go to the other side. The PC100 and the orange cable come in and it reaches that just fine. So now with my other EFI, I had a wire running from the computer in here outside to a different fuel pump relay. So I'm getting rid of this one, or I'll use the slot for something else. But the wire that controls the fuel pump was usually this one, and it comes off of this one here, because that's the ASD output. And one of these is the fuel pump trigger wire. So I'm gonna run the fuel pump trigger wire out through the engine firewall to my GM style fuel pump relay, because all this needs, it's already hot wired in, and all it needs is a trigger wire, which is right there because it already goes to the fuel pump back on the frame rail. So I'm just going to run a blue wire, so I always know that's my fuel pump trigger wire, and it's going to ground this wire to activate the fuel pump. So I'm putting everything in there now so I can verify cable wire lengths to see what needs to be shortened up, if anything needs to be shortened, or if I can just wrap it all up with some protective sleeve like that back there, or just wrap it up in tape since it's all going to be protected. It looks pretty simple now. This is just my 12 volt constant hot wire, my yellow wire, the ODB2, but that's it. Let me get this all wired up so we can see if this engine starts. Ran my fuel pump wire, my blue fuel pump wire, which is now a ground for the relay, fuel pump relay. And I grounded, I drilled a hole and grounded my whole wiring harness with an extra ground strap, and I used one of the spare wires that I had cut out of the car harness, which comes off that main ground. Then I have the other one coming off the C100, or the other set of grounds, and the C100 ground. Yeah, I know you can't see that, but all these grounds are tied together to the PCM case, and then this one's also tied to the PCM case. So we're using it as ground, and then we're grounding to the body right here, because I've got a big ground cable between the negative of the battery and the block and the frame, so that I never have to worry about that. Remember, electrons from a battery flow negative to positive. So actually, your whole body, your ground plane, is supplying all the juice to all your components. So your red wire is just acting like a return to send all the electrons back to the positive of the battery. All right, so here's my fuel pump relay. And this is my extra tab I have on here that I could apply 12 volts to while I'm standing here. And on my other card it has a push button, so that it's a test button, so you can send your fuel pump 12 volts. So what I'm doing here, I just have a hot wire running to my battery. It's a fused wire running to my battery, because I don't want to hook a car battery up to the whole system yet till everything's hooked up, because I've got like the starter wire is just hanging there. Don't want that touching ground and killing the battery. So right now I've got the fuel pump hooked to my test battery, to my switch, and this is grounded to the body. This yellow wire is my ground, and then my positive, it's red, goes to my switch, so I can flush my fuel tank. The gas in this car has been in here for about 2 years. I haven't driven this thing since I pulled the small block out of it and sold all my small block parts, because I'm strictly Hemi now, or 440s. I've got a 440 cast crank motor there I'm looking for a flywheel for, and then a steel crank 440 out of a motorhome. One of these is going back in my 70, just because it's a big block car. So small block cars are getting these Hemis. So what I'm doing, I'm flushing all the gas out. Look how yellow that looks. I know it's supposed to be clear. So I'm just flushing as much as I can out, and I've got 2 5-gallon cans full of gas I just filled up during the week. So I'm just going to turn on my switch. I've got the fuel filter hooked up, and everything's going through my EFI filter. This is like for an 84 Cadillac. I think it's a 4502. You can look it up, a Duralast 4502. It actually accepts a brake line fitting, which is an inverted flare at one end, and then a hose barb at the other end. So what I'm gonna do, I might just put a hose on there and put an AN fitting on here, but I might flip the fuel rails so that this is now on that side, and then I can just put a 90-degree AN on it. See, look at this gas. You have to be careful that you don't have any sparks around your gas fumes, because this is just pumping raw gas out of my gas can, my gas tank. So I'm gonna put it into a 5-gallon can. Let me shut this off. See how yellow that gas is? So I'm gonna be careful and take this out of here now. Probably filter it and put it in my lawnmower, back into a gas can with a funnel, and then put fresh gas into this thing just to flush out the lines. It'll probably run on this, but I don't want my Hemi running on old gas when I can easily replace all the gas with the new gas. Okay, just showing how to flush out your tank. My old fuel system had a fuel pump, a fuel pressure regulator over here. That's why this comes in here. and then it went through the lines, it went through the rails, the rail went over to this other side, and then the return is over here. So this was my return line going back to the tank. So unless I change the rails, I can still set it up this way, but then I have to put a regulator back on the other rail, like on the Cuda. So what I'm thinking is put the Corvette style regulator in the back, hook it up to the line. This is all brake line, bent down and around, down to the frame, and then just pull this other one back and just use it as a vapor vent line, because that goes all the way back to the tank, to the vapor separator. So just showing this. All right, let's go on. All right, this is what fresh gas looks like around here. See, it's nice, clear and yellow, but it's not dark yellow like the stuff I was showing coming out of my tank. So I'm glad I'm pulling all that out and putting the fresh stuff in. Time to tackle the gas pedal. So with the Cuda, I made a whole bracket that went up in there and tilted the pedal arm down so that I could just shorten the end of it here. And it was at the right angle. But I figured that's too much trouble for this car. So we're trying to do this simply. And these are original pedals here. And you can see this one is smaller. I think this one is off my 70 or 72. It's a bigger footprint. And this was off of this car. It's a little smaller and it's spring loaded in the back. So I think this one had a spring. It's just not there now. So this was just in my stockpile. So what I'm gonna do, it's about the right height, just at the wrong angle here, okay? So I have its base. I took off that big mount that comes with these pedals and screwed it right to the firewall, flat. So that any modifications I'm going to make to this angle is going to be right here at this bend. I'm going to chop that off and maybe screw a bracket to it that I can weld. And then I'm going to chop one of these factory pedals off because it's got the right angle and the right lean, just like that one. The Challenger pedal, Charger Challenger, and it's got a lean to it. These are all a little bit different depending on what application you use. So I am going to cut it about here where it gives me that bend. I'm going to make a bracket that bolts to it, maybe on each side, just a piece of metal that I can weld to. And then I'm going to cut this probably right at that bend. And then weld it to the piece of metal that I am going to bolt to that pedal. Maybe one on each side and put this shaft up the middle of it. We'll see. It's just, right now it'll work. It's just, it's too high up. And it should be even with your brake pedal. So with power brakes, your pedal is dropped a little bit. So I want that even so your foot can just go right from your brake pedal to your gas pedal on the same plane without having to raise your toe up. And it's more comfortable driving that way also. All right, so we're going to cut this off and make something up. All right, so here's the hole without the pedal. What I did was angle the pedal where I wanted it, and I made a bracket so that this pedal is sandwiched after I chopped off the part I didn't need. It was angled up too high. So it's sandwiched between the two pieces left of the plastic. And then I welded the arm at the right angle that I want for my pedal to sit, so that it sits level with the brake pedal and also doesn't hit the floor and bottom out when you go to full throttle. And there it is installed. So it's just the right distance away. It's almost the same height as the brake pedal. And has the spring-loaded top section in there with the screw that holds it in. But there's the bracket before I paint it. You can see the pedal goes all the way to the floor without bottoming out on the carpet. And I did have to use a shorter pedal. I had a shorter pedal and a longer pedal like this. You see it's a little longer. Shoot. Here, we'll hold it like this. See, so there's a taller pedal, but it actually hung down lower, and it might have hit my mat when I was installing it, so I ended up swapping the two pedals for the shorter one, because I didn't want to cut up this assembly, because this is nice and painted compared to my other one, which was a little rusty. So there it is. There's my pedal without a lot of modification to the bracket up there. It just goes right onto the firewall with some big flat fender washers and some bolts just going through the two holes that mount the pedal. There it is. You can pull it out and paint it, plug it in, and try to get this thing started. Alright, I'm doing the wiring that's coming out of the bulkhead connector here. And I'm going to use another spare harness because I don't want to cut this one up. But let me explain what all these ends go to and how I'm going to hook them up. Alright, so normally your connector here is one of the plugs of the bulkhead out of the 4. This goes to the ballast resistor, one end. This goes to the other end, the run wire. So one actually goes to the start wire on the ignition switch. This is the run wire on the ignition switch. And then it goes to the coil, the positive of the coil. This is for the tach, which I can leave out too, because the tach is going to be driven through a different driver little board. So what you can do, this is my Saginaw tilt column in this car, and this is laid out the same way. Start puts the juice down one of the wires, and then when you put it back on run, it switches back to the other wire. So if you had something like a race car, I would do the start switch with like a diode between the run wire and the start circuit to keep them separate, if you had one switch controlling both. But in this case, we tied these both together since they're isolated in the ignition switch, and that gives me my 12-volt switched. I'll verify with the meter that when this ignition is on start, you're getting power through one of the wires, and when you put it on run, you're getting power to the other wire, and then it doesn't drop in between no matter how slow you turn your ignition switch back from the start to the run position, because if you have any break and lose power, your computer system will restart. So this was for the tach. This is for the voltage regulator for the alternator, which isn't needed. This is going to be the water temperature sensor wire. This goes to the alternator, the 2 fields on the alternator, and this is the charge wire on the alternator. This goes to your horns, these two green with a red stripe, your horns, and your windshield washer pump motor if you have an electric pump. So I can get rid of most of these wires and tie them in from the inside to my computer system for the switched on signal. And then the rest of these can be taken out. I need this one. This is normally the oil pressure wire for your gauge, either if you have the on-off idiot light or the rally temperature gauge. This is the wire it uses for that. So I'm going to eliminate these two. This one, probably hook the tack, reroute it to the inside. Leave that one. Leave the horns, and leave the windshield washer and the water temperature. Everything else, you know, the blue wire comes off the run wire also over here. Everything else can be pulled back. I could run this wire as a parallel circuit to my circuit breaker, because this is actually coming off the alternator, and this one originally came off the alternator, and that gives you a parallel circuit into the bulkhead and dashboard, because the amp meter is bypassed and I have a voltmeter in its place. So just wanted to talk about this. I do have spare wiring harnesses, so I don't want to cut this one up in case somebody ever wants to switch this car back. It's not all chopped up, and it'll just go in my wiring box.